Hi everyone, thanks so much for joining this video. Today we're going to look at some harder questions using Hess's law. So the first question says to calculate the standard enthalpy change for the following reaction using the enthalpy changes given. So what I like to do first is to write out the equations for combustion and for formation, so I know exactly what I've got. So the enthalpy of combustion of sulfur, the enthalpy of combustion is when you completely combust 1 mole of the thing you're finding the enthalpy change for. So that means that we have 1 mole of sulfur and we completely combust it in oxygen, and these are in their standard states to form sulfur dioxide. And this is actually already balanced, so this would be my equation. And then we look at the formation of water and of H2S. So the enthalpy change of formation is the enthalpy change when 1 mole of the thing we want is formed. So that means that 1 mole of water is formed. And so from its constituent elements, we need to form 1 mole of water. So using hydrogen in its standard state and oxygen in its standard state, we need to form 1 mole of water in its standard state. And that means that we must have half of an oxygen because now it's balanced. You need to remember not to put any numbers before the water, because the whole point of the enthalpy change of formation is that 1 mole is formed. So if you change that, then it won't work. And then for H2S, so making it out of hydrogen gas again, and then plus sulfur, which is solid, and then we need to form H2S, which is a gas. And as you can see, this was already balanced, so this will be the equation. And now we have a look at how we can combine these all together to find the delta H of this reaction. And so first I like to write out this equation, plus 2H2S gas, and I call this the enthalpy change of reaction. Okay, and now we can see that the sulfur and the oxygen, I can combust the sulfur to form sulfur dioxide. So if we have a sulfur here and add it with an oxygen, we can form this sulfur dioxide. And then with this hydrogen sulfide, we can form it using hydrogen and sulfur. So if I add a hydrogen and a sulfur, then we can form hydrogen sulfide. But then we've got 2 hydrogen sulfides, so that means we need 2 of the H2 and 2 of the sulfur. And then looking at this bit, we now have balanced this equation as well. So we've got 1 sulfur here and 2 sulfurs here. So the enthalpy of formation of this sulfur is 0 because we already have the same thing here. And then we have oxygen and water, and this will form the 2 waters here because this is the equation for the enthalpy of formation, but we've got double that amount, so it all works out. So here we have the enthalpy of formation of the 2 H2Os, and then here we have the delta H of combustion of the sulfur, and we have the delta H of formation of the 2 H2S's. And now we can work out what we know and what we don't know. So the delta H of combustion of sulfur we know is minus 297. So we can work this out as minus 297, and then you plus 2 times the formation of H2S, which is minus 20. And this turns out to be minus 337 kilojoules per mole. And now we work out this enthalpy of formation of the two waters. So we would do 2 times, and 1 water is minus 286. So we do 2 times this, and this equals minus 572 kilojoules per mole. And after we work these two out, we then have a look at the diagram and see how we can find this enthalpy change of reaction. So Hess's law states that the enthalpy change is independent of whichever route you take from start to finish. So if we call this the start and this the finish, then that means that if we go this way round, the enthalpy change will be exactly the same as if we went all the way round. And because we know this and we know this, we can then find the enthalpy change of reaction. So if I label this X, this way we would have minus 572, and that should be equal to, this is minus 337 plus X. And so rearranging for X, we can then find the enthalpy change of reaction. So X turns out to be minus 235 kilojoules per mole. So the enthalpy change of reaction is minus 235 kilojoules per mole. So before I start on the second question, feel free to pause the video and try it yourself first. So calculate the enthalpy of combustion of CS2 given the following enthalpy changes. Now first I start off by writing the equation for the enthalpy of combustion of CS2. So we know that 1 mole of CS2 is being combusted, fully combusted with oxygen. So it goes to completion. So we form carbon dioxide gas and also sulfur dioxide gas. And now we just need to balance it. So we can't change this because it's in the definition that we're combusting 1 mole. So that must mean we have 2 sulfurs. So if I add a 2 here, we then get a balanced equation if I balance the oxygens. So we have 4 oxygens plus 2, so that's 6. So we need 6 on this side, and we've only got 2, so that means we need 3 oxygen molecules. And this is the delta H of combustion of the CS2. And now we have a look at what we have. And so we have the enthalpy of combustion of the carbon and the sulfur. And then we have the formation of CS2. So that means that we can add the constituent elements of CS2 together to form CS2. But the definition of enthalpy change of formation is that it's the enthalpy change when 1 mole is formed. So we need to form 1 mole of this. So we need to balance this so that I have 2 sulfurs here. And so this is now forming this. And then we can combust carbon. So if I add an oxygen here, we can form the carbon dioxide because I'm completely combusting 1 mole with oxygen to form carbon dioxide. And then the same with the sulfur dioxide. So I can combust sulfur with oxygen completely to form sulfur dioxide. So then I can add on, well, normally it would be sulfur plus oxygen goes to form sulfur dioxide, but because we have 2 moles here, we need to double the amount of everything. We've already got 2 sulfurs here, so we need 2 oxygens. And so now this will be the enthalpy change of formation of the CS2, and this will be the delta H of combustion of the carbon and also the delta H of combustion of the sulfur. And now we work out all these numbers. So the delta H formation of CS2 is plus 88. And here we have minus 393 plus minus 297. You need to times by 2 actually. So it would be 2 times minus 297. And when you add these together, you get minus 987 kilojoules per mole. And now you think back to the diagram again, and you have a look to see where I could start and where I could finish. So I think I can start here, and I can finish here, because we know what this is. So we know the enthalpy change when we go this way, and we can work out what the enthalpy change this way, because it'll be exactly the same as this. And so we can work out this enthalpy change of combustion. So then we have minus 987 equals 88 plus the delta H of combustion. So then we rearrange to find the delta H of combustion, and that equals minus 1075 kilojoules per mole.